Good morning. My name is Don Malloy. I'm with Auth, and I'm also the chairman of Oath, the Initiative for Open Authentication. Today, I would like to speak with you about how an Auto OTP can provide the foundation for zero trust security and convenience. So, I'm going to talk a little bit about us very briefly. The problem of existing identification and financial authentication, an introduction to mutual authentication, and using out-of-band mutual authentication with biometrics, and then mutual authentication, how it works in an open banking and omni-channel world. So Auth is a mutual authentication technology provider. They have developed products such as an Auto OTP, one-time password that's automatically configured, an auto password product line, and a filing box, which is a ransomware prevention product. So let's talk a little bit about the breaches. Most businesses still take over 200 days to detect a security breach and 80 days to respond and contain it. The prevention-based techniques that are used are now inadequate, so detection and response is the future for effective security. Cybercrime, it's a growing threat. I started putting this graph together with 4 companies 10 years ago, 12 years ago, Apple, Google, Sony, and EMC, and RSA. And look at that. Look who's on it. All the Fortune 500 companies are part of it now. And I could keep adding more and more to it, but I don't because it just gets so absurd. But we all know where we're going. So some information about what's going on. The number of web attacks blocked per day has increased about 56% in just the last couple of years. The data breaches have skyrocketed to over 1,000 in 2020. The numbers even higher in 2021. Office applications were the most commonly exploited. An 80% increase in the number of people affected by health data breaches in just 2 years. So where is this going? You look around, identity theft is 69% of the breaches. 16% is financial access, and 7% is just account access. And existential data, it's 5%, nuisance is only 3%. Most of it's done by malicious outsiders, 72%. And about 18% of it is accidental. Now, this is just one data set, and there's more. So how do breaches happen? So over 4,800 websites are compromised with form jacking code. Third of all data breaches involve internal actors. That's a little higher than what we saw in the last graph. And 71% of the breaches are financially motivated. Ransomware is 24% of all the incidents where malware is used. And 95% of all the records came from either government, retail, or technology. Over a third of the breached data breaches actors were involved in organized crime. And we saw the numbers 228, well here's 329 and 233 days respectively. The data breach time is getting longer and longer, and this is unacceptable. 48%, almost 50% are Microsoft files, Office. So looking at the costs, it's anywhere from $7 million in healthcare of a single data breach to 6 and, average 4.5 to 5 million for energy, financial, technology. And if you're a small company, $5 million for a data breach is pretty substantial. So looking at just some of the recent data breaches, Microsoft had 280 million records. Over 10 million guests at MGM Grand were posted on a hacking forum. 500,000 Zoom accounts were found for sale. 60,000 customers from Ancestry.com. 235 million Instagram, TikTok, and YouTube videos. YouTube profiles were exposed. Mashable had almost 2 million records of their staff and subscribers that was leaked. Spotify had an undisclosed number. California Department of Motor Vehicles. Now, we know that there are at least 25 million data records in the California Department of Motor Vehicles. So the risk, a financial services employee has access to over 11 million files. The average DDoS attack grew more than 20 to 26 gigabits per second. DDoS attacks rose 278% in just 2 years. over almost 10,000 attacks were between 10 and 30 megabits per second. And 5% of the company's folders are protected. 38% of all users have a password that never expires. Almost 30% of data breach victims are small businesses. A cyber attack occurs every 39 seconds, and 23% of them are caused by human error. So just looking at some of the largest data breaches and hacks over time, look at these numbers. They're astronomical. 380 million, 275 million, 420 million, 412 million, 164 million. They just keep going on and on. A business will fall victim to a ransomware attack every 11 seconds. Cybercrime is going to cost the world over $10 trillion. That's bigger than most budgets of most countries, all but a handful. Attackers are going to focus on biometric hacking. Skimming is new, but it's the next frontier. And ransomware as a service is starting to pop up. Online gaming is going to be the emerging hack surface. So what are we going to do about this? Where's it all going? So look at what we're trying to accomplish. So we're trying to accomplish an open banking, omni-channel banking system where you can use one device to get onto all your access to all your portals. Well, this is the way it's supposed to work, right? You have your bank or whatever your device is that you're connecting to and financial authentication. And it's broken. It's not really working like it's supposed to work. And the reason for that is because, we have, user ID, password, OTP, SMS, PKIs, biometrics. We're doing 2FA or MFA, but there's a precondition of this user authentication technology. And that's the fact that we think the server that we're thinking that we're connecting to is always authentic. But what if it isn't? What if we're connecting to a bad guy and we don't even know it? So here's a man in the middle. And so we're trying to connect to our bank. We think it's our bank, but we're not really connecting to our bank at all. We're connecting to a false actor. So we give them our security code, and they come back with an SMS code. So every mobile authenticator is designed for checking whether the user has the right authenticator. But what about the server? What about authenticating to the server? This is where we need to start working and focus our efforts. So we get a common sense approach. User-only authentication. And this only authentication technologies are added. Security is not dramatically increased. So banks are making it harder for the customer to make their service secure. So they're putting the burden on us, and that's not the way it should be. So a better way is to decrease the customer burden while increasing the bank's security. We're going to have user-only authentication, and we're going to do it with a mutual authentication. This is where it's needed, where most of the trust is required. We're going to do this with Auto OTP. Okay. Here we're going to see a demo of how it works. I'll put in username, password, log in, and now the bank comes back to you with a code. You have to authenticate that code on your phone. You have the same code. So it works. So now you touch your biometric, or you just say OK on your phone, and then your authentication is completed. And now you're able to perform your transaction. Whether it's your bank or shopping, this is how it's going to work. So here we're authenticating from the service. So the server is authenticating to us before we give up any credentials. That's the key. So if we take the OTP with the user authentication, we have the Auto OTP for an online authentication. And here we're going to look at it again. So here's with logging in. You type in password, your name. You get your authenticating code right there, and it shows up on your phone. And there it is. And now you get a request whether you want to authenticate to that. And you say, yes, I'm going to authenticate for this before the countdown comes down. And then you're able to conduct your transaction. You're able to get onto your server and make a payment or do whatever you need to do. So this is where the user authentication comes in, okay? And it updates the password all the time. So it's always updating the password. So it's an Auto OTP. And this has been certified by a number of agencies and organizations. So if you think that this mutual authentication is similar to mobile push, it really isn't, okay? Every mobile authenticator is designed for checking whether the user has the right authenticator. But, like I say, it also, if you're connected to a fake system first, then you're going to be authenticating to the wrong person. So we need to authenticate by the servers. So bank IDs and authentications, they've been fragmented underneath this multi-channel banking service. We can use ID cards, PIN codes, OTPs, passwords, SMS, PKI, fingerprints, voice, facial recognition, doesn't matter. We're going to use all these things to authenticate to our bank. But for the Omni-Channel Banking service, if you think that the customer's smartphone is going to be an authenticator, well, it's not. But with Auto Password, it can be. So here we are at an ATM. We put in the username, and we go to authenticate, and we get the code, and it comes up on our phone, and we can authenticate. So the bank is going to us first before we're giving a server any information. And then we get authenticated. So this is a token using either telephone or voice-assisted banking. And here we're using a biometric, getting the code, and now we're authenticating. So it's coming to us, and we're getting the code, and we're saying yes by authenticating to our device. We can do third-party providers, whether you're purchasing something from a website or you're doing banking. So here's you're trying to buy something online. So we don't want to be talking to the fake server first. So here we go, we got a shopping cart. And we're trying to go to the checkout. All right, we're going to make a demo bank to confirm it. And now we're going to put in our ID. So username, we log in, and then here it comes up on our phone. We get that same authenticator, and now we just OK it. And then the purchase is going through. We authorize the purchase. Here's a Windows demo showing the same thing. So you get into Windows Server, and here comes the code onto our phone. We authenticate. We say, oh yes, and it's authenticated. And now we're in to do our business. Also works on Linux. So we're logging in as demo, and then enter the key. Here comes the authenticator. 082.219, and we just hit the enter key to continue. And then it works, and we're connected. So it can work on any platform. This is the key. You can do it on a mobile application as well. So here you have them from mobile to mobile. You get the code, and there's the code coming back up, and you authenticate to it. And then it's done. Happens to be partially in Korean. So with mutual authentication technologies, you can change. You can change a lot of things. So we can go from an open banking, omni-channel banking, which was kind of broken, as user-only authentication, using whatever it is, PKI, OTP, SDP, Biometrics, or we can go with an Auto OTP, an auto password, an open banking omni-channel system using mutual authentication. So this is B2C or G2C. So here's a web portal, and same issue, same login. This is the Online Privacy Association in Korea, which has settled on this. So why do users have to memorize and type passwords? Why don't you let the server do it? Let the server worry about the passwords. This is the key thing. As I said, it's certified by a number of companies, FIDO and IBM and whatnot. So are you interested? You can get a free month trial. Contact me. One of these methods. Thanks very much. I hope you enjoy this conference and have a great day.